So you see before you triangle. And I'm going to want to rotate it around this center of rotation. Yep. There it goes. That's kind of hard to do if I don't have numbers, isn't it?
Yes.
Now, would it help if this was the origin?
Yes.
Would rotating that be a lot simpler? Yeah, because then when you want to rotate it, you can just say, okay, wherever X, Y, and Z are, I can just yoink and move them over there. Sadly, though, we are not on the origin. I want my center of rotation to be over here now. That's going to be real goofy, huh? And so to test it out, how that's going to look, let's put it on a graph, and I want to try something. Up here, this has been rotated around point P, okay? And from point P, when it got rotated, it's rotating 90 degrees counterclockwise. You can see it's going counterclockwise here, around this point. You're like, okay, yeah. Look at the points and tell me if there are a pattern. So where is point A? Someone find point A and tell me its coordinates. You might have to use more than one hand.
Big 4, 6.
4, 6?
Yeah.
Okay, and where's B? Someone else?
6, 7, 8.
6, 7 or 6, 8?
6, 8.
6, 8. And C?
5, 4.
5, 4? Cool. Now, I want you to find their images. So I want you to find A prime, B prime, and C prime. Just find their ordered pairs. Start counting. C prime. And remember, P is not the origin. Okay, where is A prime? Has somebody found that one?
-1, 5.
-1, 5. And the next one? B prime?
-3, 7.
-3, 7. And C prime?
1, 6.
1, 6? Perfect. Is there a pattern of switching X's and Y's here?
No.
Is there a pattern of positives and negatives here? No. Well, that sucks. Because that means all those wonderful rules we learned for rotating yesterday don't work if you're not at the origin. But see, here's where what we learned in day 1 is going to come in handy. Because what I'm going to do is I'm going to take what I learned there and say, okay, yeah, around the origin it was okay, but around this point, I don't know how to rotate. But remember, I have little things called vectors. And when I rotate my shape, guess what rotates with it? The vectors rotate. And so what we're going to do today is we're going to use those rotation rules we came up yesterday and use them on the vectors. And say, okay, if I have these vectors, I'm going to use my rotation rule on the vector and then use the vector to figure out where my new triangle should be. Okay? So that's a 3-step process. Can you remember 3 steps?
Yes.
If not, well, I don't know what to tell you. You'll have to refigure out how to do this every time. But that's going to be our goal for today. So in your notes, you have a first problem here. And it says consider triangle XYZ, and you've got these vertices. And what I want you to do is see where your point of center of rotation is. Is it the origin? No. So can I use my fun rules on my points? No. But I know how far I need to go. I need to go 90 degrees counterclockwise. What is my rule for 90 degrees counterclockwise? What was it? It's negative y, then x. I can't use it on my points, but I can use it on my vectors. What's my only problem? Do you see any vectors here? Did they tell me any vectors?
No.
Could I graph the vectors?
Probably.
You can. Do I need to graph the vectors? No. Remember, vectors, you can just do the math. So my first vector is going to go from this point P, and which one do we want to go to first? X. So I'm going to draw, not even draw, write the vector from P to X. And so you go, okay, how do I get from P to X? Well, P starts at 1, that's my initial point. What's my terminal point? Goes to 4. How far did my vector go to get from 1 to 4? It went 3. And then you look at your second component. To get from 2 to 7 from P to X, how far did that component go? It went up 5. Who'd I lose? Now could you do that for your other 2 points? Can you find the vector from P to Y and the vector from P to Z? If y'all will do those really quick, and see my hand wants to automatically do parentheses, but we have to use the little pointy brackets. Okay? Find your vectors Py and Pz. Remember, you're starting at 1, 2, and going out to those points. Let's see. Okay? So here are those vectors. What are the amounts? The first one has 3, 5. Okay? What about PY? What did PY end up being? Yes?
7, 3.
7, 3. So it said to go left 7 and up 3. And then the last one? Yes? Right 5 and up 1. So let's see. So I got to go over 3 and up 5. 1, 2, 3, 1, 2, 3, 4, 5. So there's that PX. 7, oh, this is not my right set of points. I should just use a blank piece of paper. I thought my old one would work, but apparently I have a different example. So pencil, there it is. So my first vector goes over 3 and up 1, 2, 3, 4, 5. There's my first vector, and it goes to P. My second vector goes over 7 and up 3 to get to Y, and then over 5 and up 1 to get to Z. Those are my vectors. Oh, look! The center of rotation is right here. How far am I going to rotate these vectors? How far does it say to rotate my vectors now? It says to rotate them 90 degrees counterclockwise. So what you're going to do now is you're going to take these vectors and you're going to rotate them as if they were points. Okay? So use your rule to rotate your vectors now. Okay? And so you think about it for a minute, okay? Instead of going from P to X, now where is it going to be going? It's going to be going to X prime. And then you think this one's going to be going P to Y prime, and this one's going to be going P to Z prime. Okay? And how did my rotation change them? Well, it should make the first thing be your flipped Y value, and your second thing be your original X value. So Dina, what do you think the first one's going to be? It's going to be negative 5, 3, so left 5 up 3 instead of right 3 up 5. PY prime? Sorry?
Negative 3, 7.
Thank you. So left 3 up 7. And PZ prime? I need a new victim. Yes. Negative 4. 4. Negative 1 is what you said, and I heard wrong? Negative 1, 5? Okay. So my vectors were going this way, and now they're going this way. Now all I need to do is figure out where those endpoints are. How do you do that? How do you figure out where those endpoints are so I know where my new triangle is? Because I've rotated my vectors. Yes, Carmen?
Plug the points into the vectors.
Well, you don't plug the points into the vectors. We move using the vector. Shh. So if I want to move using this vector, where does this vector say to start? At P. And then I'm going to move this far to get to x prime. So if I want to go to x prime, I have to start at P. How much is P? 1. And then how far am I going to go?
Negative 5.
Down 5. So what's down 5 from my point at 1? That's going to be at negative 4. And then if I start at P being 2, I need to go up 3, and where does that end up at?
5.
It ends up at 5. So my point should be at 4, 5. Let's see if that matches what my coordinates said to do. Get lined up here, so I should be at negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Right there. Okay? Where will y prime be? Well, I start at P, so I start at 1 and go negative 3, and then 2 goes positive 7. So where do you end up at? I think 1 minus 3 is negative 2, and then the 2 plus the 7 gives you 9. So y prime should be at negative 2, 9. Let's see. Negative 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. It did end up where I wanted it to be. So now let's use our vector to get to z prime. Where does it start?
1, 2.
At P, 1, 2. So 1 is going to go down 1 and end up at 0. 2 is going to go up 5 and end up at 7. Let's see if I'm at 0, 7 when I do that. Oh, look, there it is right there. So just by using our vectors, we can keep the same old rules we had before and just move our vectors instead of having to move points. And it makes things a lot simpler, so you're not recreating rules every time. So come down here, and I'm going to give you another thing to do. I want you to do another rotation. What things do you need to look at before you begin? Your point of rotation. Is it the origin? No. So am I going to rotate points or rotate vectors? Let's rotate some vectors. Okay, how far am I rotating them? Because I need to know what rule to use. 180 degree rotation. So that rule says to take xy and move it to what? Negative x, negative y. So all my vectors are just going to switch the signs. So first now, find your vectors. Where are all our vectors going to start? At your center of rotation, A, at negative 3, negative 1. And if you want to save yourself from mixing up, start it all together. So I need to do A to C, I need to do A to D, I need to do A to E, and I need to do A to F. I've got to find all those vectors. So you're finding those movements. Remember, vectors are just movements. Okay. So A to C starts at A, -3, and moves to -7, and starts at -1 and moves to 6. So does somebody have the AC vector? Alan?
4 and 7.
4 and 7, does that sound right? Anybody want to argue with that one? Is it, well, let's see, I started at -3, went to -7, that is down 4. Okay, direction matters. If you're starting -3 and go down to -7, you got to move down 4. But -1 to 6 is up 7, so that is a +7. If you're not sure, could you draw the picture and literally trace it? C is going to be at -7. 1, 2, 3, 4, 5, 6. And so the vector does go left 4 and up 7. Okay. Okay. So A to D now. D is at -4. 1, 2, 3, 4, 5, 6. How do I move to get from A to D? What's 7? There's got to be 2 numbers.
Oh, sorry.
He was saying.
You were saying something else?
Because he was realizing.
Okay, so from A to D, I got to go from -3 to -4, which is how far? That's a down 1. And that, look, that's a left 1. And then from -1 to 6,
7.
that is another up 7 move. Okay. And then from A to E, that's a really small vector. That's just a little guy. So you start at -3, you go to -4. How far did that guy move? -1. And then we're still on E. See how I've labeled everything? It helps me keep track of which one I'm on. I've got to go E, so -1 to E is at 1. -1 to 1?
0.
Well, don't add them. How far apart are they?
2.
They are 2 apart, and I'm going up from -1 to 1. Draw it if you need to keep yourself from mixing up your directions. And then the last one, A to F, you start at -3, go to -7. Which direction is from -3 to -7, Ryan?
Down.
Down. So it'll be a -4. And from -1 to +1, is that an up or a down? Negative to positive. That's up, and it's going to be up 2. Okay? See, all those positives and negatives you learned back in 7th grade are really useful. And so that thing is going to be going left 4 and up 2. And so that's that vector there. So now my 4 vectors are drawn. Okay? Now we want to rotate them. So I want to take these guys and use my rotation rule to get them to where I want them to be. The rule says to do -x, -y to all my vectors. Okay? And so now instead of AC, I'm going to have AC prime, and then AD prime, and then AE prime, and then AF prime. And figure out where those vectors are. And I'm going to have to put AF down below it because I just don't have room. Now what does your rule say to do to each of these vectors? Just make your signs opposite. And so, okay, so AC prime is going to look like what? +4, -7. And AD prime is going to look like 1, -7. Psst. And then A to E prime? It'll be see, I make the negative switch to a positive, and the positive switches to a negative, and then negative switches to positive, positive switches to negative. So cool, now my vectors over here, oh, hold on, I forgot, I always have to mark where my verticals and horizontals are so I can turn the right amount. So I'm going to turn around my point of rotation now it should be going, those are all my new vectors. Is this an over 4? See, it should go over 4 and down 7. Did I do it far enough? Nope, that's a 90-degree turn. Okay. Remember, I've got to rotate it 180 degrees. This is a 180-degree rotation. So I should have come down here. Now do I have an over 4 and a down 7?
Indeed.
Indeed. Okay. So now I know I've done it right. So my points should all be down here. How do you find your points now? How do you find C prime? I use these vectors to move from my point of rotation to your new image points. So 3, -1 has to move right 4 and down 7. So take this 3, -1 and move it right 4 down 7. And do that with all of them to find A prime, C, D, and E, and F prime. Okay, so go ahead and do those. You're writing. And since you've already done one, where did C prime end up?
7, -6.
And I'm going to change color here. So you're at 7, -6, and somebody with D prime, let's see, D prime should start at -3, should move right 1 to -2, and then to get to D prime down 1 and -7, -1 down 7 should be what, -8?
Wouldn't it be -1, -6? Because the -3.
Let's see, I had a -3,
Oh wait, it's good.
and I move up 1 to -2, and I start at -1 and move down 7 to -8.
I was talking about the
Oh, the C? Let's see, it started at -3. It should have moved up 4 to +1. Yes, good, you caught that. Go get candy.
You really did well in seeing that.
And -1 to -7 is down 6. So yeah, got to be real careful. And this is what I meant about the tedious part. These numbers are all lower than 10. None of these are more than the number of fingers you have. But it's easy to mix up which direction am I going, what letter am I working on. And so it's just tedious, it's time consuming. E prime. Well, to find it, I'm going to start at A and go to E prime. So start at A, I've got to start at -3 and move over 1 to -2. Start at -1, move down 2 to -3. Did I do good? Did I do it right? And now a victim for the last one. Where is F prime going to go? And nobody wants to be the one who speaks up because there's hardly anyone here and you pick it. You okay, Sophia? What did you get for F prime? Okay, so do it with me. So where do I start to get F prime? You're always going to want to start at that center of rotation. And so that's A. And then to get to F prime, I need to move using this vector. Well, let's see. If I started at -3 and I went up 4, where do I end up at? +1. Good. And then if I have -1 for my y and it goes down 2, where do I end up at? -3. That's how you use those vectors. So now when I have this vector here rotated, let's see if those are the points we landed on. I should have landed at 1, -6, 1, or is that -1? Should it have been a -6?
Wait, why is C prime -6? It should be -8.
Yeah.
Oh, it should be -8?
Yeah, why?
Well, hold on, but it was that started -1,
Yeah.
down 7 should have been -8. Okay, so 1, -8. Ah, that's much better. That's right there. So that did go where we wanted it to go. D should be at -2, -8, right there. -2, -3, and then 1, -3. Could you, if you wanted, literally take some tracing paper and rotate it just to make sure you're doing it right? Sure. Nobody's going to stop you. Yes?
Are we allowed to do it on the test?
Absolutely. I have a whole box of this paper. Okay? That's a good way to check. Hey guys, when you rotate though, mark a couple of horizontals and verticals just to make sure you go the right amount. Okay? But yeah, you can totally do that and check to see if you did things right and see if stuff is goofy. But that's all you do. Your steps are write the vectors from your center to each vertex, rotate the vectors using your rule, and then use the new vectors to find your new points. So I'm going to write these shorter. So my first step was write vector from center to vertex. Step 2, rotate the vectors. And then step 3 was use new vector to find new points. And that's your rules. That's what you do. It is not difficult work to do. It is tedious, it is annoying and time consuming. Would you like to do another one together, or would you like to work on the problems and be checking them consistently throughout the remainder of the period?
Latter.
The second one where you work on your homework but you're checking all the time?
Yes, I like that.
And the first page is the old stuff actually. So okay, you can use the remainder of the time to start working on the assignment.